Hello everyone, I am Assistant Professor Amruta Mahangare from Department of Physics. Now we are going to discuss some important concepts related to MPSC or for MPSC. So our topics are measurement, motion and laws of motion. So let's discuss the first one point, that is the measurement. Okay. So why we need a measurement? So measurement plays very important role in our day-to-day life. Okay, means for example, when we measure some mass of the mass, then the measurements are required in measurement of volume, measurement of length, measurement of temperature. So these are some examples in which we need measurement, right? So why or what is the need of this measurement in physics, we can say that, or in our day-to-day life. So to understand any phenomenon in a physics, we have to perform some experiments, right? And the experiments required measurements. And we measure several physical properties like mass, length, time, temperature, pressure, etc. So these are some physical properties we use in our day-to-day life. So experimental verification of laws and the theories, there also needs measurements of physical properties. So this is all about the need of a measurement in our life. So here we just discuss about the physical quantities. But what is meant by these physical quantities? A physical quantity that can measure and described by a number, and that quantities are called as the physical quantities. Okay, so if we consider the example, then for example, mass of a person, if we measure a mass of a person, then it is 65 kg. Length of a table is 3 meter. Area of a hall is 100 meter square. Or temperature of a room is 300 Kelvin. So when we measure a mass, length, area, temperature, so when we measure this physical quantity, we describe that quantities by a number, and that's why these quantities are called as physical quantities. Means here we describe that measurement in this manner, we can say that. So this one, it is a number, and this one, it is a unit of that physical property. Means here we measure a mass, so 65 it is a number and kg is its unit. Similarly, like length, 3 meter means 3, it is a number, and m or meter, it is a unit of the length. So this one, it is a explanation of that physical quantities measurement, we can say that. Okay, so there are the different types of the physical quantities. So what are the different types of the physical quantities? So the first one type is known as the fundamental quantities. So which quantities we call the fundamental quantities? So the fundamental quantities are described as follows. Means the definition is the physical quantities which do not depend on any other physical quantities for their measurements are known as fundamental quantities. Means these are the independent quantities, we can say that. Means if we measure the physical quantities, then measuring that physical quantities that do not depend on any other physical quantities, and that's why that quantities are called as the fundamental, that is the basic quantities, right? So for example, mass, length, temperature, time, so these are some fundamental quantities. And opposite to that, the second one type, that is the derived quantities. So derived quantities, it is opposite to the fundamental quantities. Means the physical quantities which depend on one or more fundamental quantities for their measurements are known as derived quantities, right? Means the examples are area, volume, speed, force. Means why these quantities are called as the derived quantities? Means when we measure a force, so we know that force is equal to what? Mass into acceleration, right? Means that is a combination of two physical quantities, or the mass, it is a fundamental quantities that depends on the acceleration, right? And that's why these quantities are called as derived quantities. So these are the two types of the physical quantities, that is the first one is the fundamental and the second one is the derived quantities. Okay. So the next one is that are the units for the measurements. So when we measure some physical quantities, then at that time we described some units, right? But what is mean by this unit? So the standard used for the measurement of a physical quantity is called as unit. Means when we measure some physical quantities, then we use some standards, right? And that is called as a unit. Means for example, if we measure a length, then we can measure length in meter, foot, inch, etc. Or also when we measure a mass, then we can measure that mass into kilogram, gram, pound, etc. Similarly, when we measure a time, we can measure second, minute, hour, or temperature. So that is measured in Fahrenheit, Kelvin, degree Celsius, right? So these are all that is called as the units for that measurements. Okay, so let's discuss these units one by one. So the first one type is that is the MKS system of units. Now what is mean by this MKS? So this system was introduced in France actually, and it is also known as the French system of units. Means it is based on meter, kilogram and second as the fundamental units of length, mass and time, and that's why it is known as MKS, means meter, kilogram and second, and that's why it is known as the MKS system of units. Okay, the second one type is CGS unit. So it is also introduced in France, but it is also known as the Gaussian system of units. Means it is based on the centimeter, gram and second as the fundamental units of same length, mass and time, and that's why it is called as the CGS system, centimeter, gram and second. And the third one unit, it is the FPS system. So actually it is a very old one system. So this system was introduced in Britain, right? So it is also known as the British system of units, and it is based on a foot, pound and second as the fundamental units of length, mass and time. So these are the three types of the systems we can say that means MKS, CGS and FPS system. Okay, so this is all about the physical quantities, its units. So these are some several fundamental units. So this table shows us some fundamental quantity or physical quantities, their units and their symbols. Means if we measure length, so it is measured in a meter and the symbol is m. Mass, SI unit, here only we consider a SI unit, not a CGS units. Okay, so time is measured in second and the symbol is S. Temperature, it is measured in Kelvin, the symbol is K. Electric current, it is measured in ampere and the symbol is A. Luminous intensity, it is measured in candela, the symbol is CD. And the last one is amount of substance, it is measured in mole and the symbol is MOL. So these are called as the fundamental quantities, or we can say that these are the 7 fundamental quantities with their SI units and with their symbols. Okay, so I hope it is clear to all. And also there are the 2 supplementary units are there. So what are that? So first one, it is the radian. Radian means what? If we measure the angle between the 2 vectors, we can say that, then that angle we normally measure in theta. Okay, so we normally measure in degree, but if that angle is very small, then that is measured in a radian. So it is used to measure plane angle, So that's why if we measure this angle between these 2 vectors, then it is theta, which is equal to 1 radian. And the second one unit is that is a steradian. Steradian means what? So it is used to measure the solid angle, right? And that's why it is known as a steradian. Okay, so these are some supplementary units when we measure some angles. Okay, so there are some rules for writing the SI unit. Means when we describe any physical quantity, or when we measure that physical quantity, we described its measurement. So while writing their units, there are some rules. So let's discuss one by one what are that rules. The first rule is the full name of unit that always starts with a small letter even if named after a person. Okay, means like that even that is Newton, Ampere, Coulomb. So we know that these are the names of the scientists. Okay, so when we write the names of that person, we can say that. So it is always written like this, small letters, even it is name of a person. Okay, so not like this. So this one it is the right one method. The second rule is the symbol for a unit named after a scientist, that should be in a capital letter. But instead of writing a full name, when we write only the letter, we can say that, or at that time we can express that letter in a capital. So like N for Newton, K for Kelvin, A for a Ampere, C for a Coulomb. Okay, so this is the second one rule. The third one rule is symbols for all other units that are written in a small letters. But if the other units when we write, and that is a name of, that is not a name of any scientist or a person, then at that time that units are written by a small letters, like M for meter, kg for kilogram, cd for candela, s for second. So this one it is the third rule. The fourth rule is one space is left between the last digit of a numeral and the symbol of a unit, right? Means when we write any number and when we described its unit, then there is a one space is left between that two digits, we can say that. Means like this, that is a 10 space kg, 5 space Newton, or N, 15 space meter, not like this. Okay, so this one it is the correct one method to write the unit. The fifth rule is the units do not have plural forms, right? Means when we explain the length of the table is 6 meter. So it is only a 6 meter, not a 6 meters. Okay, only the mass of a duster is a 14 kg, not 14 kgs. So when we write down any units, so that do not have the plural forms. So this is a wrong one method, this is a correct one method. Okay. The sixth one rule is full stop that should not be used after the units. When we write the units, so the full stops are not required. Only write 7 meter, 12 Newton, 25 kg. So this is a wrong method, this is a correct one method. The seventh rule is no space is used between the symbols for units. Means when we describe the derived quantities, so that is a combination of two physical quantities. Means at that time the two units are required there, right? So no need to give a space between that two symbols. So write down like this, that is a 4 joule second, 19 Newton meter, 25 volt ampere, like this. This is a wrong one method, this is a correct method. So these are some rules for writing the SI units or any units. Okay. So these are some SI prefixes we can say that. Means their factor, their symbol, their name. So this one it is a short one we describe. So normally we use 10 raised to 9, that is a giga, 10 raised to 6 mega, 10 raised to 3, that is a kilo, and also we use a centi, that is 10 raised to minus 2, milli 10 raised to minus 3, micro 10 raised to minus 6, nano 10 raised to minus 9, pico 10 raised to minus 12. So these are some common units we used. Okay, and these are some use of the SI prefixes, right? Means if we write 3 milliampere, so 3 milliampere, so we can write down also that is 3 into 10 raised to minus 3 ampere, because we know that the milli it is a 10 raised to minus 3. So we can write that into this way. Also 10 nanosecond, so we know that nano means what? 10 raised to minus 9. So we can describe or we can write down that is 10 into 10 raised to minus 9 second. So these are some examples of the previous table. Okay. So also these are some practical units for measurements. means when we measure bacteria's, we can say that, so we can measure 1 micron is equal to 10 raised to minus 6 meter, molecules 1 nanometer is equal to 10 raised to minus 90 meter, also like nucleus. So we know that, so these are some practical units for measuring the lengths. Okay, so this is all about, we can say that, the measurements. And also similarly, when we describe the units, so we can convert that unit one form into another form, right? Means we discuss about the types of the units also. So this one, it shows the converting lengths unit, right? Means if we want to convert kilometer from kilometer to meter, meter to centimeter, and centimeter to millimeter, then at that time we multiplied by these numbers to that specific number, right? And when we convert millimeter to centimeter, centimeter to millimeter, and meter to kilometer, then we divide that specific number by these number, right? That's why here I described that numbers in a red also and blue also, right? So the examples are as like this. So if we want to convert 5 kilometer into meter, means 5 kilometer is equal to how many meters? So kilometer to meter conversion. So here we want to multiply by 1000 to this number, that is a 5. So 5 into 1000 is equal to 5000 meter. So this one is a correct conversion. 120 centimeter is equal to how many meters? So now here the conversion is centimeter to meter. So we want to divide that number, that is a 120, by 100. So here 120 divided by 100, which is equal to 1.2 meter. So in this way we can easily convert any number or any quantity from one form to the another form, right? So this one, it is a conversion length units. So this is all about the measurement, right? Now we are going to discuss about the next one topic, that is the motion. Every day we experience motion, or we know that what is meant by motion. So if we define the motion, means when a body, it is continuously changing its position with respect to the frame of reference, then at that time we say that the body is in motion, right? So this is definition, or we know that, and the common examples of the motion. So the car constantly changes its position with respect to the given path, right? Or some athlete running in a race continuously changes his position on the track with respect to the audience that watches him. So these are some examples of the motion. But there are also the two types, we can say that, or there are the two types, that is the scalars and vectors. What is meant by these scalars and vectors? So the motion of objects that can be described by the words. So that words such as the distance, displacement, acceleration, velocity. So these quantities are either vectors or scalars. Means there are the two categories, we can say that, to describe these physical quantities, and that are scalars and vectors. Okay. So just we discuss about the motion, but this motion occur in a different types, we can say that, or there are the different types of the motions that we experience, that we observed. So what are the different types? The first one is, that is a linear motion. Second is the curvilinear motion, means the circular motion. In that the rotatory motion and the revolution motion are included. Third one is the oscillatory motion. Next is the reciprocal motion, vibration motion. So these are all the types of the motions. Okay. So this one figure, it shows us the different types of the motions. Now let us discuss the one by one the types of the motions. Okay. The first one is, that is a linear motion. When we say that the motion, it is a linear, so when any body or any object, it moves in a straight line, then the linear motion is called. Then that motion is called as the linear motion, or it is also called as the rectilinear motion. And the examples are, just we discussed, that is athlete running on a 100-meter race track along a straight line, then it is said to be a linear motion or rectilinear motion. So this is the first one type. If we consider the second one type, then that is a curvilinear motion. So when a body or any object that moves along a curved path, then that type of the motion is called as the curvilinear motion. So there are the two types of the curvilinear motion, means the rotatory motion and the revolution motion, which is also described there. So let us discuss the first one, that is a rotatory motion, or it is also called as the rotation motion. So when we say that the body is in rotatory motion or a rotation motion, so a body is said to be in rotatory motion when it stays at one place and turns round and round about an axis, then that time we say that the body possesses rotatory motion or rotation motion. And the examples are the rotating fan, a spinning top and the earth. So these are all examples of the rotation motion. The next one type is the oscillatory motion. So when the body or object is said to be in oscillatory motion, so when it swings to and fro about a mean positions, right. So we normally observed one example, that is a pendulum of a clock. So or the swing, so that is a motion that is a to and fro about its mean position, and that is why this motion it is called as the oscillatory motion. Also the swing machine of a machine, it is also the type of the oscillatory motion. So these are all about the oscillatory motion. So this is all about the types of the motions, means the different types of the motions with their example. And the last one point is the Newton's laws of motion. So there are some laws of this motion. So what are that laws? So we know that there are the 3 Newton's laws of motion. So let us discuss that laws. The first one law is the law of motion, or it is also called as the law of inertia. So what is the statement of this? The statement is every body will continue in its state of rest or of uniform motion in a straight line unless it is acted upon by some external unbalanced force to change its state. So that is called as the first law of motion, or this one statement, it is the first law of motion. Means when we kept one duster on a table, right. So the first position of that duster, it is at a rest position, right. Means that duster is not a moving until when? So when we apply some force on that duster by hand or by any other way, so what happened? By applying that force, that duster moves from one place to another place, right. Means the body or that object, it has no ability to itself to change its position or to change its motion, and that is why that type of the motion, or that is called as the first law of motion, that the body could not change its position until when we apply some external force on that, and that is called as the first law of motion. Okay. The second law of motion is, means in short, that is F is equal to m into A. So this is the second law. So what is the statement is, the rate of change of momentum of a body with time is directly proportional to the net external applied force on it, and change takes place in the direction of the force, right. Means what happened? When any body is in motion, then it possesses acceleration and momentum. Then if we consider the p bar, it is the momentum of the body, and the applied force on that body, it is the F bar. So F bar, it is the external force acting on that body. Then according to the statement of the Newton's second law, we can write F is directly proportional to the rate of change of a momentum. That means F bar is directly proportional to dp bar divided by dt, or we can write this like as F bar is equal to k into dp bar divided by dt, where this k, it is a constant and having a value 1. So we can write that is F bar is equal to dp bar divided by dt. So we know that p bar means what? It is the momentum or linear momentum, means p bar is equal to mass into velocity, that is a mv. So we can write this equation as like this, F bar is equal to d divided by dt mv bar, right. So the mass of an object that does not change, so we can write F bar is equal to m into dv bar divided by dt. But we know that dv bar divided by dt is equal to acceleration, that is a bar, and if we substitute this value in equation, then we can write F bar is equal to ma bar. So, if we write a magnitude of a force, then F is equal to ma, means force is equal to mass into acceleration. So, this one, it is the second law of motion, Newton's second law. And the last one law, that is the third law of motion, and the statement is, for every action there is always equal and opposite reaction. Means what? When we punch on a table or when we punch on a wall, then what happen? We apply some force on that table or a wall, and at that same time simultaneously that table or that surface of that table or surface of a wall, that also exerts some force in our hand, but in opposite direction, right? Means if we press a surface of a table by our finger, then our finger gets bent in a little manner. Why? Because we apply some force on that table, so simultaneously the surface of that table also some exert a force on our finger, means in equal manner but in opposite direction, and that is why we can say that this every action there is always equal and opposite reaction. So, if we consider some example of this law, so whenever here we can say that the objects A and B that interact with each other, then what happens? Then that two objects that exerts forces on each other, right? So, this one it is an example of a third law. Or also when we sit in our chair, then the chair or our body exerts some force in a downward direction on a chair, and at the same time the chair also exerts some upward force on our body. So, this one is also example of Newton's third law, and also the common example we can say that there is a rocket, there is a motion of a rocket, action and reactions are happen here. Means when a rocket fuel is ignited, then the hot gases produced at that time and the gas molecules collide with the inside walls. The walls also exert some force that to push them out of the bottom of that engine, right? And that is why that engine goes or the rocket goes in upward direction in a fast manner, we can say that. Also the baseball forces the bat to the left, the bat forces the ball to the right. So, these are all some examples of a Newton's third law of motion. Okay. So, in this way here we discuss about the measurement, motion, its types and the laws of motion. Okay. Thank you.